In the next 3 videos, I'm going to walk you through the steps of hypothesis testing using a one-sample t-test. And in this video, we're just going to get a little practice to get us warmed up. So we're going to review the 4 steps of hypothesis testing in the next 3 videos, and we're going to apply the steps actually to several different scenarios. So when we are talking about the t formula, it is, as a reminder, the mean of our sample minus the mean of the population divided by the estimated standard error of the mean. So we have a ratio. The numerator, again, this is review, is the actual difference between our sample mean and the population mean. And the denominator is how much difference is reasonable to expect between the sample mean and population mean just based on random error. So numerator is our reality. It's the data that we have in hand. And the denominator is what we would expect. It's kind of like the ideal, what we think is going to happen in terms of how much our mean would be different from the population mean. When obtained difference between our data and the hypothesis is greater than we expected, the denominator or the standard error, the estimated standard error, this is going to give us a large value for t. If you think about it, when we have a ratio and the number on the top is a lot bigger than the number on the bottom, the actual answer to the ratio or the result is larger. So when the difference that we are seeing between our mean and the population mean is a lot more than just the difference we would expect to see by random chance, that gives us a larger t value. And an extreme t, or a larger t value, means that the null hypothesis was wrong, and we reject the null hypothesis. So let's do this example. We have a sample of with an n of 16, and it produces a t of 2.54. So we need to think about, if we're doing a two-tailed hypothesis test, what would be the correct statistical decision? Let's map this out. So for n of 16, our degrees of freedom are going to be 15. And this is a two-tailed test, and we're really trying to figure out, let's go back, we need to figure out 0.05 and 0.01. By the way, answer D, you're not allowed to say that. All right. So we're going to circle 0.05 and 0.01 in the two-tailed test area. So basically, we're then going to draw down to see what is the critical t-value at 0.05 and what is the critical t-value at 0.01. At 0.05, the critical t-value is 2.131. At 0.01, it's 2.947. So the question was, if we had a t of 2.54, would we reject the null at 0.05 and or at 0.01? Well, is 2.54 more extreme than 2.131? Yes. So in this case, if we had our alpha at 0.05, we would reject the null hypothesis. We would say there actually is a difference between our sample mean and the population. But if we were at a 0.01, our critical t-value there is 2.947. And in this case, our t-value of 2.54 is not as extreme. It doesn't fall into the critical area. And so we would fail to reject the null hypothesis in this case. We would say that, yes, our mean might be different than the population mean, but that's just sampling error. It's not anything that is meaningful. So that is our answer. We reject it at alpha 0.05, but not at alpha 0.01. Let's say we had a sample with an n of 25 and it produced a t of 2.86. What is the correct decision? Again, we're going to be looking at 0.05 and 0.01 levels, and you are not allowed to say, I have no idea. So n of 25 means that we have degrees of freedom of 24. And we are looking for a two-tailed test at 0.05 and 0.01. So I circled those two. Now I'm going to find what the critical values are at each of those levels. So at 0.05, the critical value is 2.064. At 0.01, the critical t-value is 2.797. So our t is 2.896. So I see right away it's more extreme than 2.064. It's also more extreme than 2.797. So in this case, we're going to reject with both alpha 0.05, and alpha 0.01. Okay, we're going to do one more with an n of 20 and a t of 1.70. But this time we're looking for a one-tailed hypothesis. What is the correct statistical decision in each of these possibilities? So we're going to be looking for alpha at 0.05 and 0.01 for a one-tailed test. You are not allowed to say, I have no idea. So here we go. We have an n of 20 and a t of 1.7. So that means we have degrees of freedom of 19. And I'm going to circle, this time in the one-tail area, 0.05 and 0.01. And I draw imaginary lines to find a t of 1.729 and a t of 2.539. Well, our t is 1.70, so it's not even as extreme as the proportion at 0.05. So we are going to fail to reject the null with alpha 0.05 or also with alpha 0.01. All right, so stay tuned for the next video where we're going to dive more deeply into an example.